So transition metals. Transition metals are those metals in the middle of the periodic table. Again, if I were to draw my periodic table, here's the periodic table. The transition metals are the one in the middle, okay? And if you recall, I'll just quickly review, 1 plus 1 or 1 plus, 2 plus. Our middle we set to skip, but they are all positive. Then 3 plus, 4 plus, but can change. 3 minus, 2 minus, 1 minus, and then of course our noble gases. We're talking, if we're talking transition metals, we're talking about the ones in the middle, from numbers 21 through number 30, and then of course down below. So those are transition metals. They're always positive, but because they can change their charge, we have to add a little something to them. Transition metals, because they change charges, we need to, we need to add Roman numerals. We use Roman numerals to describe what the charge is. And then Roman numerals tell you the charge. Not how many there are. A lot of people think of how many there are. It's not how many you are, it's what is the charge on the substance. So for example, iron is Fe. And iron, number 26, iron can form multiple different charges. It's always positive, but they can change their charge. We can have iron with a 1 plus charge. We can have iron with a 2 plus charge. We can have iron 3 plus, and we actually can have iron 4 plus as well. All those are perfectly fine. They all become stable electron configurations. It has to do with the outermost electron energy level, and where those electrons are. But all of those can be stable, and therefore they can form those charges. To differentiate, this iron with the 1 plus charge is going to be iron Roman numeral 1. So we would call it iron 1, whatever it might be. Iron 2 has the 2 plus charge. Iron 3, and of course iron 4 is the, again, respective charges. The Roman numeral tells you the charge. The charge is the Roman numeral. And I repeat that a few times because obviously people see the subscripts, or in other words, how many there are, and they think that's what the Roman numeral is. It's not that. The Roman numeral tells you the charge. So let's say we have iron 1 oxide. Okay, so there's the name, iron 1 oxide. Let's take a look at what the formula is for that. Well, iron 1, the Roman numeral 1, tells me I have a 1 plus charge. Oxygen, I look it up on the periodic table, it has a 2 minus charge. Notice if I have a 1 plus with a 2 minus, I need 2 of those irons to balance off the 2 minus charge. So again, however you think about it, I like thinking Fe, they both have a 1 plus. Oh, I only need 1 of them. So notice I need 2 of the Fe's to take care of that 1 oxygen. So notice that iron 1 oxide, the name iron 1 oxide, you actually have 2 irons. 2 irons, again, the amount of them is not what the Roman numeral is. The Roman numeral is what the charge is. So that's how you describe the transition metals. If I do another one here, I'll give you the formula. In order to figure out what the charge is, you just take a look at what it's with. So let's say I have CuP, okay, copper with phosphorus. Now the name of this thing is going to be copper something, because copper is in the transition metals. If you look at your periodic table, you have your periodic table here. Copper is smack dab in the middle of transition elements, transition metals. So it's going to have a Roman numeral because it can change its charge. Now, copper something phosphide. Again, it's phosphide because It's a monatomic anion. You drop the ending and you add the IDE. Now, what is the copper in this case? How do you figure out what the charge is? Well, the copper is a question mark. We know it can change, but phosphorus never changes. Phosphorus is a 3-. Now, since it's a 3-, we check it how many we have. We have only one. All right, only have one. And since we only have one, the total net charge negative is a 3-. Now, how many coppers do we have? Well, we only have one copper as well. Only one copper. Since we have only one copper, it must be a 3+. Why must it be a 3+? Because that 3+ and 3- must cancel off. So the Roman numeral in this case is copper 3 phosphide. And please notice that the formula itself, CuP, it doesn't have 3 phosphoruses, it doesn't have 3 coppers, but the name is copper 3 because phosphorus has a 3- charge, therefore copper must also have a 3+ charge to bounce off that 3-. So that's your transition metals. It can get a little confusing, but that's the basic idea.